Agrenaisha Korja. My name is Paul Cunningham and welcome back to the third day of IST-Africa 2022. This is the final session on next generation computing, featuring presentations from the UK, Kenya, Mauritius and eSwatini. So our first presentation in this last session today is Responsible AI, the SDGs and AI governance in Africa.
Hello. First of all, let me begin by thanking the organizers for organizing this very important conference. My name is Dr. Kutoma. I'm Associate Professor at Montfort University, where I work within the Center for Computing and Social Responsibility. I'm going to talk about our paper, which is Responsible AI, SDGs, and Artificial Intelligence Governance in Africa. But before I do that, please allow me to acknowledge my co-authors, George Oho, Damien Eke, and Simi Akintoye, who are all at Montfort University. I wanted to begin by looking at the motivation of the paper. The motivation has really been a simple one, which is really related to the fact that there is a growing potential of artificial intelligence in Africa. And we see this through figures who acknowledge this particular aspect, such as the Secretary General, Antonio Guterres, who indicated that artificial intelligence can be used for social good back in 2017. And I think in his reference to AI as useful for social good, his reference was obviously related to how artificial intelligence can be used for development aspects in order to help achieve the Sustainable Development Goals, for instance, or indeed to help the development of both the Global South and the Global North, because we know that there are challenges that need to be addressed at a global level. And these have been well articulated in the Sustainable Development Goals. And so also part of the strand then of our paper was really to understand how we can then look at the use of artificial intelligence in the attainment of the UN Sustainable Development Goals and what the implications are, particularly for African countries. And in so doing, we felt that we also needed to look at the aspect of artificial intelligence governance structures and policies, because without AI governance structures and policies, we believe that it is very difficult to actually attain the UN Sustainable Development Goals. We also then wanted to explore the relationship between responsible artificial intelligence governance and the aspect of Sustainable Development Goals. So what does that mean in terms of ensuring that SDGs are achieved, are attainable? How can we use, or how can we use artificial intelligence responsibly in order to realize this particular aspect? And so we then got to looking at our research objectives, which were threefold. And these were really the first one was really to make a case for the development of artificial intelligence governance structures in Africa, because we felt that there was a very limited, and not only the fact that we felt that there was a limited understanding or take-up of artificial intelligence structures in Africa, but that a case needed to be made in order to ensure that AI governance structures were actually becoming a reality, because we know from our research that there's actually very little that has gone on in terms of AI governance structures in Africa. And I also wanted to look at possible implications of what it means to have a limited or a lack of governance structures when it comes to artificial intelligence, because of course then this actually raises critical questions around, for instance, ethics and social economic, legal related aspects when it comes to AI. Then we also wanted to present recommendations after we looked at the paper in more general terms. So our research approach looked at 2 AI policy tracking repositories. These one is related to the OECD AI Policy Observatory, and the other is the 2020 AI Readiness Index, which was developed by Oxford Insights and the International Research Development Center. And these are quite authoritative in terms of AI policy tracking because they actually kind of give a proper picture of what is happening in terms of AI policy or AI strategies that are being developed across the globe. So for example, the Oxford Insight Repository has a special category that looks at responsible AI sub-index, which is a tool dedicated to measuring how responsibility is actually being looked at by governments in terms of AI. The repository also is quite comprehensive and widely used when it comes to AI policy tracking. And the other aspect that we looked at was the study by the European Parliamentary Research Services panel for the future of science and technology, STOA, which is a European Parliament Directive General for Parliamentary Research Services. And these are actually very important, particularly in terms of what they look at or bring when it comes to national and international strategies on artificial intelligence. And so they are quite an authority when it comes to AI issues in different quarters in as far as artificial intelligence is concerned. So this is what we use to sort of inform our research, or indeed our research outcomes in as far as our methodology was or is concerned. So the major outcomes when we're looking at the methodology that we developed was that the 2 repositories actually showed a lack of AI readiness in as far as AI strategies are concerned when it comes to Africa. So what this showed was that, in layman terms, is that Africa ranked among the lowest in AI readiness. And this was, of course, due to the fact that there was limited or very little that was going on in terms of AI strategies or policies. There were only a few out of 54 countries in Africa. So you can imagine that it doesn't really paint a very a broad picture in terms of what is happening when it comes to artificial intelligence strategies or indeed policies. So we had, we noted countries like Mauritius, Egypt, South Africa, Seychelles, and Tunisia, which had AI strategies. But then this was quite different when we looked at the global north, including countries like Canada, the US, Europe, the EU countries, and indeed UK. These had robust artificial intelligence strategies and policies, which obviously resulted in high AI readiness for these particular countries or geographical locations in as far as AI is concerned. So, and one of the reasons for this was because there is evident high artificial intelligence investment. The policies or strategies, if you like, also address the ethical and social issues related to artificial intelligence. There is also recognition of a combination of the importance of looking at industrial and technological strength within a regulatory framework that is actually based on fundamental values such as related to ethics and social aspects of what artificial intelligence might actually be when it comes to these particular countries. So the strategies in essence, were consistent with the country, with these particular country values, the interests, the priorities, and the policies that were put in place. And this was quite different when we looked at Africa and African AI strategies, or the lack of thereof. And also one of the things that we noted was the fact that AI was developed mainly from the global north. And I think this is not really surprising, because when it comes to the development of that technology, we know that for the most part, or most of the time, technology is developed from the global north and then adopted by less developed countries, and Africa being the African continent being one of them. But then I think what is interesting is the fact that these AI leaders, or leads, if you like, obviously from the global north. They're big technology corporate companies that are actually investing in artificial intelligence, which actually tells us something about the importance of artificial intelligence. But also, I think what this then brings to light is the fact that there is somewhat of a power imbalance, or there is potential to have a power imbalance and bias when it comes to AI. Because obviously, what happens then if there's, if there's the development of AI by a certain quarter of the globe, there will be significant influence, and there'll be less competition. And then, of course, there will be that perpetuation of asymmetrical power relations when it comes to AI. And that also kind of breeds a technology dependency. It also allows monopolization of this particular important technology, which is supposed to be used for social good. And this increases the aspect of inequalities and exclusion, particularly in decision-making in terms of artificial intelligence systems. And that in itself then brings into question whether there is this digital AI colonialism that is developing. So rather than then applaud the fact that AI is increasingly getting into Africa, and it is, there's a lot of talk of it being used for social good. There's a lot of talk of it being capable of, decreasing the imbalances or the gaps that exist between the rich and the poor. When we have power imbalance, it actually then, in certain instances, can actually perpetuate the imbalance and the biases that are already there. And it brings then into question whether AI can actually be used to achieve and attain the Sustainable Development Goals, and to what extent this can actually happen. And one of the reasons for this is really related to who is, as I indicated, who is making, decision-making processes, who is sitting at the AI table, particularly when it comes to designing, development, implementation, deployment, training, and skills development, and indeed the use of AI. Because if there are certain people that are excluded, it becomes very, very difficult to attain these much needed developmental aspects that we are talking about when it comes to achieving or attaining SDGs. And the reason for this is quite simple. And the simplicity lies in the fact that technology is always value-laden, even though it is normally presented as if it is neutral. So developers, for example, designers, implementers, will normally present a technology as if it can be useful and it can achieve the desired aspects equally across different categories of people, or indeed across different countries. But when you have the exclusion, as I've indicated, of certain groups of people in the design process, the development process, the implementation, the deployment, and indeed the training and use, the opposite is actually the case, because it becomes very difficult to understand the actual needs of the people that are merely recipients of the product that is designed and developed by others. And so we then get issues around what is embedded in AI, because, as indicated, the values are different, the priorities are different, and the expectations of that particular technology is going to be different, because obviously values differ, because developers have their own values that are going to be embedded consciously or unconsciously within these particular technologies. So the question really is, whose values and interests should be embedded in the design and deployment of artificial intelligence? What are these, and how are these values being pushed through AI governance mechanisms? And we see that these values can be pushed when it comes to, for example, autonomy, when it comes to ethical aspects related to privacy, when it comes to inequalities, and indeed when it comes to unfair discrimination and bias, because we have all heard about the biased algorithms behind artificial intelligence. And one of the reasons for this is because there is a lack of diversity of data, or indeed of the things that are actually embedded in the AI that is developed and that is then expected to be used by everybody else. And this then also brings about issues around gender bias, ethnic minority biases, because what is fed into the system is what will actually come out of the system. It is like the old adage, computer adage of garbage in, garbage out. So AI will actually replicate the values that are inculcated in its design, in its development, in its implementation, and then, of course, in how it is used and adapted. And so it's very important to look at responsibility in what is the AI technologies are designed, in how the AI technologies are developed, are implemented, and are adopted and used, so that this then can allow the values, expectations, belief system, societal needs and interests of everybody else that is going to use, particularly those in the African, in Africa, to have them reflected in these particular different steps or elements of the processes of AI development. And this can only come through proper artificial intelligence governance, because we know that without proper governance structures and policies, the very aspects of values, of expectations, of priorities will not necessarily be reflected if Africa is not taking or is not developing the AI strategies that are very much needed. Because then what will happen is that the lack of AI governance can actually have an impact on sustainable development goals through the continued discriminatory biases. So rather than achieve, for example, gender equality or end poverty, what can happen is that without proper AI governance structures and policies in place to actually ensure that these things are not happening, the opposite might be happening, because then the gender gap becomes even greater, because of course there would not be the policies put in place to ensure that gender biases are removed. The aspect of autonomy, for example, may not necessarily be reflected without proper governance structures, because there are no governance structures to actually look at this particular aspect. How do autonomy aspects how should autonomy aspect be dealt with? How should privacy aspects, when it comes to, for example, healthcare, when it comes to the management of our data that results from artificial intelligence, be dealt with? If there are no AI governance structures and policies robust as they should be, if they're not there, then it becomes very, very difficult to achieve equal healthcare, to achieve proper education aspects, because the fact that the people that actually need education, for example, through AI, if they can't afford these particular technologies, and if they cannot afford them because of a lack of proper governance structures, then it becomes difficult to ensure that there is equality under education, that there's equality when it comes to both men and women, when it comes to getting jobs, or indeed when it comes to things around climate change, things around ensuring that equality as a broad sort of basis for achieving SDGs is carried out. So one of the things that needs to be done when it comes to attainment of SDGs is really to harness AI, particularly through sound governance structures that are grounded in clear epistemological understanding of what Africa needs, particularly when it comes to social, economic, legal, ethical aspects of technologies, of artificial intelligence technologies. And these can only be done via AI governance policies. And so one of the things that we ought to be looking at is really to improve, and this is related to recommendations that we've come up with in the paper, is to improve regulatory and governance structures. And this is important in terms of building trust, in terms of encouraging early adoption of AI in Africa. Because if there are no improved regulatory and governance structures, there'll be very little trust. There'll be very, without trust, then people are not necessarily going to be adopting artificial intelligence because they don't know, they will not understand what it is all about. There will be suspicions in terms of what it can actually do for them, because they would not have been made aware of the importance of AI, particularly through policies, through AI governance structures, if they're not there. And there's also needs to obviously address the technological, political, social, legal, and ethical questions raised around artificial intelligence. So one obviously needs to look at the amount of data that is collected if we're looking at AI and healthcare. So how does that data, how is that data managed? Who manages that data? And are people aware of how that data is shared when it comes to it being used through artificial intelligence? And there's also then the aspect of the need to promote African ethical principles and cultural backgrounds when it comes to the implementation and the shaping of artificial intelligence, because again, this is related to the values that needs to be embedded in artificial intelligence as it is being implemented, as it is being designed, as it is being adapted and used. There's also the need for stakeholder consultation, and I think this goes back to the aspect of trust and the aspect of adoption that I've mentioned in the first bullet point on improved regulatory and governance structures. A lot of times there's very little to no stakeholder consultation in terms of how people think AI might actually be useful for them, in terms of how it might, they think it might impact on them. So having different voices, for example, through civil service, for instance, policy makers, academics, industry, is actually very important in order to appreciate the AI potentials and possibilities. And then, of course, the last one, I think, is the need to embed artificial intelligence into schools' curriculum. This is very important because capturing the essence of youth at a very young age ensures that there is this trust that is being built, the confidence that is needed at a very young age, and also it also ensures that young people become familiar with the technology, with the new technologies that are being developed for their use, for their eventual use as they progress to adulthood. And this is very important because for the young to begin to feel they belong at the technology table, and in this case at the artificial intelligence table, it's very, very important for them to be involved in the designing process, in the development process, in the implementation process, because then it becomes easier and it becomes something that they recognize at a very young age, doesn't become foreign. And it also then allows them to be innovative and be able to feel that they can compete with their counterparts, be it in the global north or indeed within the global south spectrum, as it were, as well. So these are some of the recommendations that we feel would be quite useful, particularly when it comes to the aspect of ensuring that there is proper AI governance structures and policies that then can help to actually achieve the much needed sustainable development goals if Africa is to move forward and be a part of this very exciting new emerging technologies, because and others that are going to come after artificial intelligence. I think the core here, the core message is really that it's important to have improved and robust structures, policies for any technology, and in this case for AI, as Africa embraces this new era. So thank you very much. And if anybody would like to have a further conversation with me, this is my email address, kutoma@tmu.ac.uk. Thank you so much.
Thanks, Kutoma. That was an interesting presentation. I mean, while I agree that traditionally underserved communities, less developed countries have been a strategic advantage in terms of being consulted as technology evolves. What I would say is that many of the issues that you've raised, which are real issues, are not unique to Africa or indeed low resource communities or countries. And I think that's something that people need to be cognizant of, that while there is a traditional view that some stakeholder groups are not adequately consulted, and I totally agree that they're not, I think that many stakeholder groups are not being consulted in the evolution of AI. And I think that's the reason why some of the steps that, for example, the African Union and the European Union have taken are so important. So, for example, the EU has a proposed law, an AI Act on artificial intelligence, and it would be the first law on AI by a major regulator anywhere in the world. And that deals with assigning risks to applications of AI. And indeed, anyone who's had any exposure to Horizon Europe, which is the follow-on research and innovation program to Horizon 2020 that Africa has been so successful in, will realize that AI aspects are very, very carefully scrutinized, both in terms of the submissions, and I know personally, having been involved in a considerable number of evaluations since Horizon Europe has started, during the evaluation process, and all of those submissions that are being considered for funding go through a very rigorous ethical review at the end to ensure that all of the kind of concerns that you've been raising are taken into account. In terms of the African Union, they set up a working group that was led by Egypt at the end of 2019 to support the creation of a common African stance on on artificial intelligence. And I think the critical issue there is that all governments across Africa need to realize that the fourth industrial revolution is coming, whether they like it or not. And that's equally true for Europe. It's not unique to Africa. And that we all need to be thinking very carefully of the implications. If we look at what some African states are doing, the South African government has invested heavily in AI capabilities through a number of research centers. And it would be interesting, both for your comments, but also if there's any delegates who'd like to comment or share insight into how AI-related expertise and capacity building are being supported nationally across Europe. The final point I would make before I hand back to you to respond and to add your own insights would be multi-stakeholder collaboration is absolutely critical in this regard in terms of the co-design, the evolution and the deployment to ensure that AI is fit for purpose and that it's going to meet societal needs, which are very different, particularly for lower resource communities, while at the same time addressing public policy concerns. So, Kutoma, can I hand back to you for a moment just to respond and reflect, because you gave us a lot to think about, and I'm just trying to synthesize some of my own ideas in real time. And then if there's any comments or questions from anybody else, please note that in the chat. Thank you.
Well, thank you very much for sharing your ideas, which very much in tandem with my own ideas. I mean, I couldn't have put it any better than you have. And I think, well, I suppose one thing that I would add is the fact that there is this, my feeling is that there is this notion, especially when it comes to aspects around data collection, for instance, when research is being done, particularly when it comes to the use of artificial intelligence, because I think those are some of the snippets that I got from some of the presentations earlier on, which were fantastic. My feeling was that, you know, as long as there was consent that was sought, you know, from, say, governing bodies in terms of interviews and things like that, then it was okay. But I think it's very, very important to go beyond that. And I think that's something that I raised yesterday when we're talking about artificial intelligence, because one of the things that is happening is that artificial intelligence is being used very much in healthcare. And that raises issues around people's data. So that in essence means that there should be elements around the data protection, for example, the aspect of privacy, for instance. What happens with that data that is being collected if there are no legal frameworks to protect patient data, for instance, because it's no longer about just doctor-patient confidentiality. There is the element of different parties that are coming in. Some of them are non-clinicians, and that just opens up a whole host of potential issues around, you know, healthcare data, some of which is very, very sensitive. But I think, in essence, I think healthcare data is sensitive regardless, right? And
no,
so,
I absolutely agree. I mean, that, as far as I'm concerned, is the third rail. It's where everything goes off the rails, because if the wrong people have access to the wrong data, you know, anything is possible. Unfortunately, we're running short of time, so I'll just add one last comment, because I don't see any hands up in the share. My primary concern in the healthcare domain, since you highlighted that, is the unfortunate contractual assertions by some funding agencies that they own the patient data for programs that are being funded. And I think that is absolutely morally wrong. And I think it's also very dangerous. And I think that just reinforces how important it is that the AU and the EC continue to collaborate in terms of informing good practices, and that nation states across the continent take cognizance of this, and particularly ministries of health don't just say, well, it's great that you're providing money, but it's important that we discuss the terms and conditions under which patient data, because it is not acceptable to us that identifiable data is owned by anybody except the patient. So I hope we'll have an opportunity to share more insights about this over the coming days. So the next presentation is focused on an IoT-based web application for tracking and managing COVID-19 related data, a case of Kenyan learning institutions.
Hello guys, hi everyone. My name is Jafer Abdikadir Hassan, and I'm a fourth year student doing computer science in Strathmore University. My colleague and I am in Gemeda, same year, fourth year, doing computer science, did a research and presenting a paper on it's called an IoT-based web application for tracking and managing COVID-19 related data, a case of Kenyan learning institutions. So basically, our research that we did was on how to track and manage infectious diseases data, but on a focus on COVID-19, and also a case study of Kenyan higher learning institutions. So basically universities. So let's get right into it. So since the pandemic, COVID-19 pandemic, so many approaches on how to track it and manage its data have emerged. So in a study of Kenyan learning institutions, universities in particular, there's so many approaches where some of the universities were trying to record the data on books. Some just, took temperature of students and let them in and their visitors. Some which tried to, keep records of the data electronically, but only the temperature data. So other data was separate and was, recorded and maintained separately from the temperature one. So for the ones doing it in a book, they had a checkpoint where, there was a staff members who had to keep on recording the students or the visitors' details over and over again. So today I'd provide my details, tomorrow again, I can repeat myself over and over. So I think you can see some of the challenges that we are trying to address. So what were the challenges that we were trying to avoid? So in a situation where, real-time accurate data is required, some of the challenges that creep up include, record keeping, where it's inefficient because it's being stored in a book or in separate places, or maybe even not recorded in some cases. So as the process is done daily, students and visitors had to keep on giving their details over and over, so which leads to redundancy. And then moreover, going near the staff, taking the information, makes them vulnerable to getting the infectious disease, in this case, COVID-19. Also, the latter leads to, issues in analysis of the data because it's being recorded in a book. So how would you know, the average temperature? It would be difficult to even share the data that you have with an institution, maybe like the government, Ministry of Health of a government, in case need arises. And some of the impacts of these problems include things like queuing, where people have to wait for some time so that they can be able to go through the tent or, pass through the checkpoint so that they can be able to get their details taken. Also, record keeping becomes inefficient because it's being done in a book. Anything can happen to the book. And how would, you get data analysis from a book? It becomes a challenge. So what were our research objectives? We had to review the current guidelines of COVID-19 screening. We had to identify the challenges related to tracking and analysis of COVID-19 screening data. We had to investigate how current approaches, techniques, and models have tried to solve the temperature tracking, identifying of students and visitors, and analysis of COVID-19 related data. We also had to identify the challenges in the current approaches, which I think I've explained. Also, we had to design and develop a mobile web app, COVID-19 management, infectious disease management information system, and also to test and validate the proposed system. So what was our research methodology and approach? So our research methodology was a bit of a mixture of experimental and build research methodology. Experimental in the sense that we had to use a pre-trained model and Azure Face API that we had to use because of its efficiency, and it has been tested in many scenarios. So our prototyping was design prototyping. We didn't use a throwaway prototyping because we kept on improving on it, and our methodology for system development was iterative. So it was incremental. So we kept on doing prototypes, incrementing on it until we got a final minimum viable product that met what requirements we had set. For doing, getting like a go ahead to do the research into a better solution of managing and tracking infectious diseases, we had to do a survey of whether the students and the visitors of the institutions preferred the current solutions. And to do such a research, the sample technique that was used was self-selection, where people volunteered to do the questionnaires and survey. So this is the proposed conceptual framework for the system. So basically, the screening data are the questions that maybe the different infectious disease may be trying to track. For the case of COVID-19, the questions were like, were you in contact with anyone who's been, diagnosed with the disease? Have you traveled outside your country for the past 14 days? That kind of questions are what I would refer as screening data in this image. So from this image, you can be able to see that someone can fill in their details, their screening question answers through their mobile phone or web application or through their laptops, because the system that was developed was a progressive web application. So you could use either your phone or your laptop to answer the questions. After that, the screening answers plus the data gotten from the entry point in the institutions, where your face has to be recognized to confirm that you're actually part of the institution and you have answered the questions being tracked, and also your temperature reading is in the right range. Those data collected from all that is analyzed by the system and then given reports through the admin portal of the application, where managers can make decisions such as which resource to allocate where at what time, depending on the traffic of entry and exit into and out of the institution. What should we focus more on? Should we focus on things like providing more of hand sanitizers or other equipment to facilitate the curb of this disease and all that? So such managerial decisions can be made using the reports gotten from the system. So what were our major outcomes? So we were able to come up with a progressive web application integrated with an IoT and developed to address the problem we had. Also, the contactless nature of the system, where temperature, you don't have to put your body near anything. It's contactless temperature sensing and the facial recognition enabled the system to comply with the regulations in this for the infectious disease, in this particular case, COVID-19. Also, an integrated approach to tracking and managing infectious diseases was realized. From the previous current solutions that I mentioned, some had separate ways to track the different parameters of the disease in question. So an integrated solution was realized. Also, the system was tested in Strathmore University successfully. We tested the system for low light conditions. Can it be able to recognize someone? What about if the high light intensity and all that, can it still be able to identify someone? And what were the accuracies of the temperature sensor? And we were able to realize the margin of error of the temperature sensor. For the facial recognition, I'm glad to say that there were no issues in recognizing or identifying the visitors of the institution, depending on whether the light was high, low, and all that. So before we go to the system demo, let me just conclude and give our outlook. So digitalization of tracking infectious diseases really improves the analysis and management of data, because it's easier to share the data, easier to analyze it. By sharing, I mean in case the Ministry of Health of the country requires the data to be shared to them, so that they can be able to maybe analyze the data from different institutions. That can be easily done if the information is digitized instead of being placed in books and maybe in separate repositories. Also, the set objectives were met because we were able to come up with a solution that integrated tracking and management of infectious diseases. Also, we recommend use of infrared cameras in future so that to eliminate the use of two different IoT devices, the camera and also the temperature sensor. Yeah, if all of it is integrated under an infrared camera, then it makes it more efficient to use one IoT device instead of two. Also, to maintain the relevance of the system can be used as an attendance system, can be modified, and actually that is what is happening at Strathmore right now. We are trying to modify the system to work as an attendance system, so just to keep its relevance. And yeah, so it's also advised that the system is hosted in Azure. Reason being, the API would be in its native environment, so it would be able to interact better there. But that doesn't mean that you're fixated to just stay there. You can be able to host it anywhere, but just to make it be in its native environment, you can decide to host it in Azure. Yes, so I think we can head to the demo part of the video. Okay, so for the demo part of the system, this is going to be the sign up page where you can sign in for the create account. These are the information we are gathering from the users, basically just the normal user identified data. But because we already have users in the system, let's just log in with one. So the system is a PWA, hence you can be able to download it as an application on your computer, phone, or anything if you don't want to keep on visiting the website. So when you land as a normal user, these are the kind of things you'll see. You'll see some screening questions which you need to answer. And in the case of COVID-19, these were the questions that were being required. So daily, you'll have to answer questions if, depending on the infectious disease that is being tracked, if we need to get this data daily, then that means you'll have to answer these questions daily. That's why we have a date over there. If the information for the infectious disease is being gathered maybe by weekly, then you'll have to fill this thing twice a week and all that. So on top of the green bar, you can be able to see train phase. So basically, when you click on that, you'll get this kind of option UI where you have to train your face. So you will open your camera, capture, and then you click on train, and then it will let you know that it has been trained successfully. As we can see, they are face trained successfully. And because we are using an API, Azure's API that is so accurate, you only need to train it once, and it will always keep identifying you. If you don't want to take a photo, then there are other options where you can upload a photo. Maybe you have a photo from your device, you can be able to upload it. If you don't want to use that option too, you can click on use your profile photo, and you'll also be able to train the model with the photo that you put. And then also you have the profile page where you can be able to see your details, edit them if you want, and yeah, change your password and everything. So after that, then that's it for the normal users. But for the admins, they have a other platform where when they log in, first of all, they'll be able to see the dashboard. But before talking about the dashboard, let's just go to identify phase, where you as the admin will be able to identify people. So you open your camera and then you just click on identify, and within seconds, it will let you know the person. And then the system will also tell you whether they've answered the daily screening question or not. If not, as in this case, it will tell you, this person has not answered the question, so you need to let them know that they should answer the questions. And then also it will let you know that you need to, register. So let's just demonstrate that you are answering the questions, and then let's go identify you again. And we see what the system will tell us next. And then after that, also it will let you know to take your temperature recording for the day, because in this case we were looking at COVID-19, and one of the vital signs that we require for tracking is the temperature sensing. So after you've identified the person, the visitor of this institution, and they've answered the question as this, it will tell you proceed to take your temperature measured, where using a microcontroller, an ESP8266 microcontroller, and a contactless temperature sensor. Using these two devices, IoT devices, you can be able to measure your temperature. So after that, you as a normal user, that's it, you are allowed into school if your temperature and your screening questions are okay. Now for the admin side, when they log in, the first thing that they'll be able to see is a dashboard, basically just to give them a small overview of what they'll see. You'll be able to see the daily average temperature, and then the average temperature since the system was installed. And you can be able to see the number of visitors in the institution. You can also be able to see a bar chart of information from when daily. If you prefer using a pie chart, then you can also use a pie chart. If you prefer a line graph, you can also be able to see a line graph. So basically, you'll see the average temperature for a specific day. And then if you want to see the highest or the lowest temperature for a specific day, you can just be able to filter that out. And you can see the highest temperature on a specific day, the lowest temperature on a specific day. And as you are an administrator, you can be able to do some user management, where if you want to edit someone's role, you can be able to edit their role and give them permissions. Maybe you want to add them as an admin, or depending on whatever role exists on the system, you can be able to do that. Then you can also decide to disable them. You can decide to delete them, depending on what you need to do. So after that, we can go to the daily records. Basically, the daily records will give you a table containing all the information that have been gathered. Now, this is the analysis part of the system. So if you need to select a symptom so that you can filter out the data, you can be able to say, I want to see everyone who had dry cough since the system started. You can be able to also choose the date wise. If you want to, maybe you want to get on 15th, how many people said they had, fever and all that. So you can be able to do that too. And depending on the question that you are trying to track, in our scenario, we had 3 questions. So depending on the question that you want to track, you can be able to filter out the results. Do I need to know question number 3, which was maybe how long have I been outside the country, or if I've been in contact with anyone with the infectious disease? If the answer was yes, maybe, or no. So you can also be able to filter out around that. So using this kind of information, you may end up being able to do some managerial decisions, such as where do we need to increase our infrastructure, where do we need to put more of our resources at, which resources do we need to add, maybe which resources do we not need to add, and basically see what will help cap the situation. So yeah, I think that's just a little demo of the system. Yes, I think that's it for the system.
Thanks very much, Jafer. So can you confirm, have Strathmore used this prototype with members of the student body in a real life context? And then I'd appreciate if you could discuss ethical and privacy related issues associated with this application and the feedback you received from the ethical review committee at your university. Thanks.
Okay, hello guys. So I hope you can hear me clearly. The system,
yes, please go ahead.
It was tested in school with 2 classes, and for that it really went well, apart from issues with the sensing part in the temperature, where I think because we were just trying to test a concept, we decided to go with a less efficient temperature sensor. But because of that, I think we kept on having issues with its accuracy. But apart from that, I think it went well. So for the ethical concerns, where privacy and all that, the system allows for users to actually upload photos. So the idea behind it was, if it's an institution, for example, Strathmore University, you just have to upload the photos of all the students who are already in the system. So these photos are already provided to the school by the students when they register, or they decide to do a course in the university. So because this information is already out there just in the school, it can be able to get access, the system can be able to get access to such information. And also because the system is, ideally it's supposed to be hosted inside the school, not to have like a third party, working on it, then it's you can say that it's unanimous that the system is just being utilized within the school. So the idea is that you're just trying to make the system be more acceptable. So instead of having it outside the school, like let's say a company decides to host everything and work on it, then that would bring privacy issues, because as a company, you don't know what they're doing with the information. But as an institution, is basically just another way of recognizing you, same as the way the institutions provide you with a student card where it has your photo and your details. So same thing to that. So because it's limited to the school's organization and it's the one maintaining its own data, some privacy issues that tend to come up if you're using third-party applications get reduced. Yeah.
Thanks, Jafer. Does anybody else have any questions or comments for Jafer? In which case, thank you very much indeed. Our next presentation is design of an AMR using image processing and deep learning for monitoring safety aspects in warehouses.
Greetings, ladies and gentlemen. It is an honor to have the opportunity to address to you all. Let me first introduce myself. I am Nabeelah Pooloo from Université Mascareignes in Mauritius. The title of the presentation is Design of an AMR using image processing and deep learning for monitoring safety aspects in warehouse. And the co-authors of this work are Mr. Wakunuma and Mr. Jafer, also from Université Mascareignes. In this talk, we are going to concentrate on the use of an AMR coupled with image processing and deep learning to solve a twofold problem, which are surveillance and disinfection. A quick view on the different topics covered during the presentation. I will first start with the problem area. Secondly, I'll focus on the research objectives. Next will be on autonomous mobile robots. I then move on with the methodology employed and the results obtained for the study. Finally, I will end with a conclusion. With e-commerce exploding, retailers have an increasing need for warehouses to store their goods for shipment. One of the biggest needs in warehouses is speed, and hence the more manpower. But it is known that fatal incidence rate occurring in warehouse is higher than any other industries. The physical demands and fast-paced environment of warehouse and storage jobs can create a number of safety hazards for employees. Common causes of accidents include spillage on floor, including floor residue or grease leading to slips and falls, material handlings, goods which are wrongly stacked prone to falling on employees, fire incidences, and finally, with the advent of COVID-19, many manufacturers have reduced staffing in their warehouses due to the need to social distancing of personnel and mingling of objects. This resulted in inventory shortages, disruption in labors, and shutdowns. The research objectives for this study are as follows. With the literature done in this field, we saw that autonomous mobile robots is being widely used in industries. Thus, we will be exploring the advantages of its use, and most importantly, how it can be deployed to assist warehouse operators as a surveillance tool and help against infection of COVID-19. Third objective is on the implementation of deep learning models, which is based on artificial neural networks. The goal here is object of interest detection, so that the AMR can act as a surveillance robot to detect fire incidences, spillage, and wrongly stacked goods which are prone to accidents. Finally, we have the autonomous navigation of AMR for sensing and perceiving its surrounding environment to make accurate driving decisions. This will be done using image processing techniques. Modern businesses are looking to improve their supply chains by shifting from traditional manual goods handling to automated processes and equipment. AMOs are essentially goods handling vehicles or load carriers operating within a warehouse in an autonomous manner. AMOs are used in a variety of applications, like movement of raw materials from warehouse to production lines, from end of production lines to storage warehouses, or from warehouses into goods vehicles. It is used to reduce damage of goods to and track exact storage location. It helps to limit risks of injury to operators through its autonomous operation. Moreover, AMO improve logistics and operations efficiency by supporting floor operations, transportation, and processing. AMOs can also take on the more repetitive, time-consuming, and dangerous tasks to save on manual labor. Additionally, AMO can help to clean the environment by injecting a sterilizer to sanitize the workplace milieu at a specific time interval. In this slide, I'm going to talk about the methodology. The first one being the path track detection using image processing techniques. Path finding is a critical component for self-driving cars, without which it is difficult to control and navigate the latter. In this study, to identify the pathway of the AMO, yellow marking lines are used on the floor. AMO will be equipped with camera to detect its path through the marking and thereafter navigate autonomously. This is done in real time with the AMO's camera on OpenCV. Firstly, image frames from video are undistorted using camera calibration technique, and the frames are filtered out by masking any unwanted colors and noise. A yellow mask is used to highlight only yellow line for the AMO and set rest of the scene of the image black. We then specify the region of interest for the algorithm to detect the line. Next is applying canny edge detector to compute the edges and correctly detect the lines. This is done by suppressing noises. It also includes operations such as Gaussian blur, subtle filter, non-maximum suppression, and thresholdings. Finally, the lane lines are then determined by using few lines function, which helps the algorithm to connect disjoint edge points in the image frame. This can be shown in figure 3. Next part of the methodology consists of detecting various mishap issues that have a high possibility of occurring using deep learning model. The model is trained to detect incidents such as fire outbreaks, spillage on floor, and wrongly stacked goods which are prone to fall. The model also helped in guiding the AMO to avoid obstacles by detecting people and machinery presence in the warehouse. To this effect, a custom dataset of 285 images retrieved from the internet consisting of the 5 mentioned clauses were annotated with bounding boxes using label IM. The dataset is split into training, validation, and testing set. Data augmentation techniques are then applied to the training set, which consequently increased to 684 images. Yellow v4 darknet is then implemented to train with the images. It is actually a state-of-the-art model for real-time object detection. After training, yellow v4 train weights are then used to make interference and test image. Let us now analyze all the results obtained during this research. Firstly is the path track detection. The image processing techniques used successfully identified the path of the AMO through the yellow design lane. The AMO path, being our region of interest, was filtered by removing any distortions. Full transform is now being commonly used in lane detection for intelligent vehicles and pattern recognition, among others. The benefit of using full transform is that it is robust against noise, but it is known to have high computational complexity. As it can be seen, the region of interest, which is the path of the AMO, has to follow, is given in blue color as shown in figure 5. Second result is on deep learning. The model based on YOLO v4 took 5 hours and 33 minutes to train for 3,500 iterations. The mean average precision, MEP, obtained was 74.40%. Some of the results obtained are as shown in figure 6. The model was able to detect the presence of people, machinery, wrongly stacked goods, fire, and spillage. Additionally, The AMO is equipped with an automatic sprayer to spray disinfecting agent at particular time interval in the warehouse. Noting that on detecting presence of people, the latter will stop spraying. To summarize this research, we have seen the various benefits of having AMOs in warehouse, how it can be used to monitor safety aspects and sanitize the warehouse ambient by releasing disinfecting agent at specific time interval. The AMO is designed to navigate through the warehouse autonomously via image processing tools whereby it is guided by following a determined path. The techniques used for this paper is processing the image followed by canny detection, then applying through-line algorithm. Furthermore, a deep learning model based on YOLO before is trained with 684 images of different classes to detect spillage and flow, people, machinery, fire outbreaks, and wrongly stacked goods as a way to safeguard the well-being of the employees working in the warehouse. The latter obtained an accuracy of 74.40%. This will also help the AMO to circulate through the warehouse without collision with any machineries and people. Although employees may be concerned that warehouse robots will replace them on their job, implementing these systems will improve the lives and jobs of everyone who works in warehouse. On a long-term view, the advancement and use of robots will contribute to a sustainable industrial development and increased productivity. I now reach at the end of the presentation. Thank you all for your attention. If you have any questions, I'll be pleased to answer them.
Thank you very much, Nabeelah. So I think we've all seen pictures of a driver driving a vehicle and colliding with a part of a shelf and then the whole warehouse falling down around them. So what are the health and safety issues associated with autonomous mobile vehicles in a warehouse environment? And what are the potential risks associated with going into an area where it shouldn't and causing damage? And in relation to tracking of human beings, how is that risk managed? Thank you.
Thank you for your questions. So first of all, I will answer the part for AMR being in the warehouse. So actually, the AMR is being able to detect people, machinery, and stack goods. So it is equipped with sensors, and having goods in front of the machine will not it will not allow itself to bump into goods. So it won't fall on people or on the AMR itself. And the risk of the AMR in the warehouse is actually people driving machinery into the AMR without it taking action in split of time. This is one, maybe. So we will have to perhaps train people to work with the AMR and having like a map with the navigation of the AMR so that people know where it is going. Other potential risk is it actually when goods fall on the AMR without the AMR hitting the goods in itself. So these are potential risks. And can you remind me of your last question?
Yeah, it was basically looking at the risk of human beings not paying attention, walking into the path of an AMR, and the AMR behavior. What is the priority? You know, essentially, it's the same risk that goes with autonomous vehicles. You know, where one of the tests is what's the least bad outcome in a crash scenario. So I suppose in a warehouse, a human being not paying attention or looking in the wrong direction walks into the path of an AMR. And then what does the AMR do if there's very little distance between it and the human being?
Okay, so for example, if on detecting people or machineries, the AMR with the sensors of the AMR will make a sound showing that it will make a beeping sound showing that it is around them. So it is a counter effect for the potential risks that the EMR may face.
No, I understand. I know I'm challenging you here, and I don't mean to do so. It's just that I know from a risk management point of view, warehouses can be noisy environments. And I don't spend a lot of time in warehouses, but I've seen warehouses where people might wear sound mufflers, for example, to protect their ears. So that's the only reason why I'm raising it. Does anybody else have any questions or comments from Nabeelah based on her presentation? In which case, thank you very much indeed. And our last presentation today is by Yves, and it's about bibliometric analysis of the application of blockchain technology for data security, a case study of Global Mission Services digital platform.
Everyone, welcome to my presentation entitled Bibliometric Analysis of the Application of Blockchain Technology for Data Security, a case study of Global Mission Services digital platform. My name is Yves Bizumuremyi, and my co-authors are Dr. Tima Mabanza and Professor Mutoni Masinde. I am currently a master's student at the Central University of Technology in South Africa. Missionary services are very important to communities worldwide. They've contributed to the growth and the development of many communities around eSwatini and South Africa. However, many of these valuable services remain invisible to people who need them because of lack of easy access to information about these services. And this brings us to our first problem area. This problem can be resolved by incorporating all these missionary services in one single digital platform. However, the fact that in such platforms, information is stored in the cloud, this can cause privacy issues. And that's our second problem area. So this paper investigates if the implementation of blockchain technology for data security could accelerate the adoption and use of digital platform for missionary services through a bibliometric analysis of scientific publication made from 2016 to 2021. The main aim of this research was to conduct a systematic bibliometric analysis in order to identify emerging trends in the application of blockchain technology for data security. Firstly, by carrying out a systematic literature review of articles about journal performance, collaboration patterns, and research constituents. Secondly, to investigate the intellectual structure of the application of blockchain technology for data security in digital platform in the existing literature. In this work, we performed the bibliometric analysis, which helped in determining the annual production of scientific paper, the country with the most publications, the collaboration, the keyword coherence, and many more. So this to be accomplished, the methodology applied involved 5 phases, as you can see on this figure. The first phase consisted of the search in the Web of Science database. The search consisted of 2 keywords, blockchain and data security. In phase 2, the information was retrieved from the database. 458 publications were found that were published between 2016 to 2021. The third phase, which is the findings, all the publication that we obtained were categorized based on their type and number of paper per year, sources, author, countries, keywords, and so on. And then in phase 4, a data analysis was done using the open source software called VOS Viewer for us to come up with the concrete data. And also Microsoft Excel was used in order to come up with graphs. And in the end, we had to document our findings. The major outcome of the results are as follows. 458 documents were retrieved, 277 articles, a book chapter, only one, proceedings papers, 158, 27 review articles, early access 20, only one editorial material, and this is in between 2016 and 2021, as we mentioned earlier on. The average citations per document was 8.02. The principal authors were 200. The subject areas, 36, affiliation 200, funding sponsors 200, and finally publishers 52. Now let's move to our first finding. As you can see on this graph, so our first finding is the number of papers published per year. As you can see on this graph, 2021 leads with 160 publications, followed by 2020, 156, 2019, 96, 2018, 41, 2017 with 7 publications. As you can see, this field is really growing as time goes. So it really shows how much authors are developing interest in this topic. The second finding is the most active authors. In the performed bibliometric analysis, 200 authors were found from the 458 documents published in the application of blockchain technology for data security. So, as you can see here, Tanwan is the leading author with 7 publications, followed by Kumar, Wang, Zhang, both with 6 publications, and lastly, Kumari. So these are the top 5 authors in terms of publications. Our third finding is the countries that have published in the field of blockchain technology and data security. China leads with the 201 publications, followed by India 67, the United States 58, South Korea 30, and Saudi Arabia 25. Now, our fourth finding is the keyword coherence. In this section, keywords coherence was done. For this to be accomplished, 84 keywords with 5 as the minimum number of occurrence were extracted from VOS Viewer in order to calculate the total strength of the coherence links with other keywords. And as you can see on this figure, blockchain is the leading keyword. It is followed by data security. We also have internet. Yeah, so basically this is the findings that we found regarding the keywords coherence. And then the results were divided into 7 clusters and then analyzed using the strength association methodology. As you can see on this figure, clusters are divided into colors. We have the red, purple, green, and all these other different colors. Moving to our fifth finding, which is the the most active collaboration. Collaboration, which is a network that shows how the authors are connected to the network because of their co-authorship. As you can see, China is the country that collaborates the most in publishing blockchain and data security articles. It is followed by India, the United States, England, Canada, and Australia. In conclusion, this paper conducted a bibliometric analysis involving 458 publications issued between January 2016 and November 2021. This study's contributions are to fill a gap in scientific words that provide bibliometric analysis in this domain of blockchain technology for data security, to determine the annual production of scientific papers in the field of blockchain technology for data security. The most productive countries, the keyword coherence, and the collaborations. Based on our findings, there are a few conclusions that we came up with. The first conclusion is that this field research is predominant in Asia, and this is because most of productions are from Asia. Most of authors are Asian authors, and this brought us to this conclusion. The second conclusion is that this research is really evolving a lot. Publication in 2021 are almost double the publication in 2019. This shows how researchers are developing more interest in this topic. It also shows how new it is and how more inputs are still needed. The final conclusion is that Africa is a little bit behind in terms of publication in this domain. The African country that tops the list is Egypt with 4 publications, followed by Tunisia with 3 publications, Ghana, Libya, Morocco, and lastly South Africa with 1 publication each. This shows that more research is still needed in this field in Africa, since the issue of security is worldwide. Our limitations and future work. The limitation of our study is that we used only one online database, which is Web of Science, and this really limited our scope. In the future, we intend to expand our bibliometric analysis using other databases like Scopus or IEEE. In the future, we also plan to carry out empirical research to fill the 2 gaps identified. The first one is the application of blockchain technology for data security within digital platforms. The second one is coming up with frameworks that ensure data security for global mission services digital platforms. I thank you so much for listening to my presentation. You are more than welcome to ask me any question. Thank you.
Thanks, Yves. Were you surprised that the majority of publications in this field now seem to be coming from Asia? Based on the repository that you looked at, and I appreciate you highlighting that it was just the Web of Science that you looked at. You didn't use Explorer or other online resources.
Thank you so much for the question. I hope you can hear me.
Yes, we can.
Yes. Well, I wasn't really surprised because I got the results based on facts, and this was based on the results that I got from the Web of Science database. I've also come to realize that a lot of, as you know, this technology is really new, and a lot of Asian university really produce a lot of papers in the field of blockchain technology. Of course, I thought maybe Asia will compete with maybe America or some other European countries. What was more surprising to me was the fact that this topic is really not much of a focus in Africa. I hope to maybe find out when I expand this research in other databases. But what was so surprising to me was the fact that Africa is a little bit behind in terms of research. Thank you.
Thanks very much, Yves. Well, hopefully, when you use other databases, you'll find that isn't the case. But I think it does highlight that this is an area that requires attention. And we've heard quite a lot about the potential applications of blockchain that will be particularly useful in low resource environments during the course of today's presentations. Does anybody else have any questions or comments for Yves? Okay, so that brings us to the end of today. Tomorrow we look forward to day 4 of IST-Africa 2022. We're starting with an invited presentation on open science policy for South Africa. And then most of tomorrow is focused around technology enhanced learning. So I very much look forward to your active participation. Again, I'd like to thank all of the presenters, and I particularly like to thank the delegates for the very high level of participation across the day. So I hope you all enjoy the rest of your day, and I look forward to seeing you in the morning. Gurumila Mahagat Slangafol.